So this is the video for Mr. Brian and all of his friends about what this little doodad does. So it's a power box to basically, well, okay, I have to explain. I'm lazy and forgetful, and I forget to turn off my audio equipment all the time. And so I figured I'd do something for that. Two things I wanted to do. I wanted to make sure that if the power goes down in the house, like say during a thunderstorm, that the equipment stays down until I turn it on manually. And also I wanted to, more importantly, do it like this. If the music is playing, a few seconds in, things turn on. But more importantly, if the music is not playing, then, you know, things turn off. So my current amp does that, and it's kind of nice. So this is basically the hub of the whole affair. It's a power distribution box. So power goes in, standard IC plug, 10 amps off the fuse in there, and then power comes out of these 3 IAC plugs that can go to consumers. So I only have 2 consumers, the amp and the DAC, but I had enough room here to do 3, and so, you know, future expansion I did 3. On the front, so these are entirely unnecessary. The only reason why I have them is because I have too much front panel room over here, and I have and I like switches. Okay. But basically one of the switches, this guy controls the control circuitry, right? And then this guy controls on and off. So before I go in more details about what's in here, there's 2, my favorite at least, electrical things that I really like. So the main power distribution system in this thing is based on a concept of a self-feeding relay. This is a classic mechanism for, you know, running an electrical motor. So it works something like this. So you got your relay coil, okay? So that's your relay coil. And then the relay will switch on and off a couple of contacts. So let's say there's like a plunger, right? And I'm just doing like an electrical mechanical drawing over here, you know, and contact plates, right? So let's call this the input side, right? So you have your input power going in here. And then your consumer side, we're going to just draw a gigantic resistor because we can, you know, coming out over here. And so normally, you know, you just power up the coil, it goes clack, and the whole thing's on. Well, that's so cool, but there's a little trick you can make to actually make this a lot more interesting. So first of all, let's call this guy neutral. All right, so this is one of the ends. We're just going to go and just run a wire to it. Okay, so we're not interested because we're going to be switching it on only one end. So the other end, just bring it out over here. Okay. So how do we turn it on? Well, let's put a button in here. And I'm actually going to put, yeah, no, for now, let's just put a button, one button, single button in here. And that's our input power. Just put a little line here, okay? So now what happens when we push the button, you know, our power goes in here. Oh, and also this assumes that this coil operates on the same voltage as it's switching, which is the common implementation of the scheme, although you could power this other power supply, but that would be unnecessary. Anyway, so when you push the button down, the coil energizes. Well, this is not very interesting because in order for a relay to stay on, you have to keep pushing the button. But you can do another trick. So what you do is you take this line. Oh, excuse me, and I didn't connect that. I messed up. I didn't connect, so I should have connected it here, of course, not here, right? Because this is already connected, sorry. So, yeah. So, anyway, going back to the trick. So what you do is you take this guy, you bring that back, and connect it right here. So now this becomes super duper interesting. So when I click the button, this energizes, it closes, which energizes this line. Oh, looky here, and it back feeds itself into the... Okay, I messed this up completely. Into here, obviously, right? So no connection here. Oh my God, I suck at this. No editing, guys. All right. So once again, we pick the power from the input side, connect it to the coil, energizes the whole shebang, this closes, and then the power now continues to energize the coil. Well, so now we solved the push button turn on problem. And by the way, if the whole power just goes down, like let's say there's a, I don't know, breaker trips, or there's like a power surge or whatever during the thunderstorms, which we have a lot of here in Texas, the thing is going to stay off, which is really cool, right? Because once the power is out, everything's de-energized, and when it's back energized, you still have to push the button to turn the thing on. So that's that. Now, but we can't turn the whole thing off. The only way to turn it off right now is to unplug it right here, right? So, well, that's an easy problem to solve. So we just go and add another push button over here. Now, this is a normally open push button. So we're going to add another push button here, which is going to be normally closed. Okay. I should have drawn it on the other side, but I guess that this gets the point across. No editing. When you push this button, you kill the feedback line, right? And now you got an on-off push button affair. And so what the box is doing is it has these two push buttons to turn it on and off, but it doubles them up. There's another one here. So this is human. That's the switch in the front. That's human. Switch in the front, manual. It doubles them up. The push button to turn things off, and I'm going to draw it properly now. That button is controlled by an Arduino. And what is an Arduino button? Well, that's a relay. So this is essentially an Arduino relay that the Arduino can turn on and off. So now Arduino, that's in the thing, has the capability of turning the whole thing off by cycling this relay. And to turn on, it's the same thing, right? So we just go and double this button up and give that to Arduino as well, right? Except that this is obviously in series, this is in parallel, right? And now it's either human or Arduino that can turn the thing on. So that's my favorite electrical trick number one, okay? My favorite electrical trick number two is, so we have a separate button to turn it on and off. And there's also the way the circuitry operates on that is, well, anyway, I'm going to show you the other thing I like a lot. So, and that is applicable to both. That is applicable to both implementing these buttons electromechanically, the human ones, as well as implementing the general control circuitry turnoff. So imagine a switch that looks like this. Okay, so I'm going to actually mechanically draw the switch. So by default, we're going to put it into the off position. Okay. And then the third position for this guy. No, I didn't draw it correctly. Let's do it again. No editing. Okay. So let's try it like this. So 1, no, not good. All right, so let me go to the other side. 1, 2, 3, 4, 5. Yeah, those will work a little better. 4, 5, 6, and then that's the wiper. Okay, by default, the wiper is connected to this guy. Okay, so on this guy, these two are connected, and on these these two are connected. So this is called a progressive switch. So this is what, 1, 2, 3, 4, 5, 6, 7, 8 poles. No, 8 terminals, 2 poles. And the way the switch works is essentially, well, you can see, right? The wipers are connected together. So when the switch is in the middle position, this circuit is turned on. When the switch is in the top position, this circuit stays turned on, in addition completing this circuit, right? So nothing, that's usually how I use them, right? It's like nothing, one of the circuits, both circuits. So the way Arduino controller is implemented on the box is this switch, okay? By default, so when it's off, it's off. So when it's in the middle position, it energizes this LED. Well, in addition to that, it also energizes the circuit that now allows me to manually turn on this relay on and off. This is the Arduino. When it's in the up position, it also energizes this power supply unit. And this power supply unit is what powers the Arduino. So in the middle position, Arduino is dead, it's off. Those are the 2 Arduino relays that act as those push buttons that I drew over there on the diagram, but it's completely off, it's out of the picture. When it's on, right? And so now but my manual circuit is still on. So I can still manually cycle power, but Arduino gets added to the mix. And this is one implementation of this progressive switch, which I freaking love. Okay, and then the other implementation is, okay, so now I'm gonna go grab another Sharpie. No, we're gonna grab a black pen because that's what I have, and I'm gonna try to move my tripod so that it doesn't flip on me over here. All right, so now imagine that instead of default position for the wipers being down there, it's actually here. All right, so that's your default position for the wipers. Okay, so now this switch, oh yeah, and let's make it momentary, right? Which means that it rests in the middle position, and then both top position and bottom position are spring-loaded. Wipers are still connected. So now this can be my always connected by default off button and disconnected by default on button in one switch. Watch. So when the wipers are in the middle, we will treat this as my off switch. See, this is connected right now, right? So in the default position, this is connected. No, am I? No, sorry, this is wrong. This, oh yeah, no, actually, this will work, but okay, fine. So in the default position, this is connected. Now, if I move to the bottom position, it's still connected. But if I move to the top position, it gets disconnected. So my top position is going to be off. And it can be reversed for the reversing of the positions, right? Now, this is going to be my on circuitry. So this is my off circuitry. Okay, this is my on circuitry. So in this position, the push button is disconnected. When I'm turning the thing off, so actually I need to draw the output. Okay, there. So this is my on circuitry. So when I pull the wipers down, this button is still connected, right? Because it's here. Maybe need another wire, right? But this gets connected, right? So this is on, and then when I want to turn it off, I go here. This doesn't change anything here, but here this line gets disconnected. So this is these progressive switches. Which is my second favorite thing. And so that would be implemented over here. So now let me actually show you how this works. So this turns on my control circuitry, enabling me to turn things on and off. And by the way, this whole shebang is flipped over. So in normal, it's going to be like that. So this is why switches are reversed here, right? So this is off, this is on, and the top is auto. The reason why it's flipped over is because the bottom is open. So if I click up, or down in this case, but up in the normal situation, that starts my relay. See, did you hear the click? And you see now my outputs, each one of these just controls the output outlet. And the LED, of course, because you need to have LEDs. All this does is enables and disables those back outlets. Okay, so this was on, and then when I want to go off. So this saves me an extra push button, right? I could have had on and off push buttons, but instead I opted to have one switch, which is this progressive switch. Okay, so the other bits in here, just so you see how this works. So power comes in here. The main power that's going to be distributed goes into the main relay, which is a 30 amp industrial finder, I believe. Is that a finder? Yeah, it's a finder relay. By the way, because of that, mistake number one, this is an AC relay, right? Remember I told you the coil wants to run on the same voltage as the thing you're distributing. And so it buzzes. So I had to add a whole bunch of padding around it so that it doesn't buzz. Okay, so power goes in, that's the main power we're going to be switching. And then it comes out, when the relay's on, it comes out of the relay, goes into this bad boy. This bad boy is, I bought it on the internet. It's a soft start board. I burnt a few fuses when starting on up big transformers, and so I figured, why the hell not? Somebody liked it. I think one of the guys actually put this thing inside of an ANK DAC or an amp, I forget what it was. But yeah, soft start board. So this is all this is. It's just a soft start board, right? So power, so off of the relay, if the relay is enabled, power goes into the soft start board, and then you see three circuits, three outputs, right? So 1, 2, 3 line. Sorry, that's neutral. Neutrals, three lines, right? And it just goes back here, distributed, right, through these three switches, right? So I can individually turn the things on and off. This little board is my LED board. So LEDs are what, I think they're 2 volt, 0.01, 10 milliamp LEDs. Just a cap, a diode, and a resistor to drive 4 of the LEDs that are powered off of mains directly. So there's no crap for LEDs that just powered straight off of 110 through this board. Then, like already said, I believe that's the power supply for the Arduino and the Arduino itself. The Arduino has 2 relays, one of which is normally closed. That's my off relay, right? When it goes normally open, that feedback loop that I had in the thing disintegrates and the relay gets disconnected. And then this guy, it's the on, right? So when these two are shorted, then the power goes to the coil relay, clicks on, and then it self feeds. Yeah, so one final thing is the actual, well, how the hell does Arduino know that there's music playing, right? How does it know how to turn the things on and off? So that was, so I thought of a couple of different implementations, and I settled on this. So this is the USB, so my source is a computer, right? So this is that USB board that looks like a sound card to my computer, and what it does is whatever comes in through the USB comes out via the SPD pins that are right under here, which are covered by that little connector. Okay, so here was my thought. I'm going to look at the SPDIF signal, and I'm going to try to interpret it. Well, I very quickly discovered that an SPDIF signal always has a square wave on it. Always, always, always. So there's always 10, 10, whatever the hell that is. I actually don't know the spec for SPDIF, nor I care much about it, and I didn't care about it. I wanted to be very, very stupid, right? I was hoping that there would be no signal on SPDIF when there's no music, and some signal when there is music, but that didn't work. But lucky for me, this board not only does SPDIF, which is over here, it also does I2S. And I mean, sure, some other format of digitally encoding audio not being used by the DAC. And the cool thing is it's synchronized, which means that there are clocks in here. See, there's clock line, RCK. And I have no idea what BCK. I have no idea what those means. But here's what I know. When there is no... So clocks always have the buzz, right? It's always a square wave, always a clock. But this guy, which is the data on there, data has nothing on it if there's no music. And when I'm playing the music, data is a square wave going up to 3.3, actually, I think. Yeah, I think it's 3.3 volts. And so, okay, this is very, very simple. First of all, see, the key point is this. The DAC, this board, this USB to SPDIF board actually is not powered by the DAC. It's powered by the USB, which means that even if the DAC, this is the DAC, right? Even if the DAC is dead, this board is still alive. So that's really cool. And all I need to do is I need to hook up the ground from this board and the signal from this board to my Arduino's analog input. And if I'm measuring more than, I decided 2.5 volts, right? Because I'm sampling 10 times a second, and sometimes I hit the upslope of the square wave, and sometimes I hit the downslope of the square wave, and sometimes I hit a 0. It doesn't matter. As long as I see enough of the high voltage signals, enough of those ones, right, I can decide that the music is playing. And so these connectors, there's a connector over here, which is like a standard 5-pin DIN old school connector. That's the back side of it. It's just 5 pins plus a shield. And this is how it looks on the business end, right? And I'm using literally 2 of these pins. Here, nothing's hooked up yet. But over there, it is hooked up. One of them is for ground and one of them is for signal, right? And so when I'm seeing, you know, my 2.5 volt thresholds or higher on that pin, the Arduino, if the Arduino is on, right, starts counting, and once 10 seconds pass, if the music is still playing, it's going to cycle the whole thing off. And then more importantly, once the music stops, meaning no signal, 10 minutes after there was no signal, 10 minutes after the last signal, rather, the Arduino will turn itself off. Well, rather, excuse me, the Arduino is going to turn the system off. And so here, this is pretty cool. So now I'm going to power the Arduino. I'm powering the Arduino. I mean, hey, I like LEDs. Everything must have LEDs, right? So now I'm going to, and this is, I haven't made the cable yet. Nothing's hooked up over there on the DAC side. So I'm just using these 2 temp lines to hook up to the actual signal line on the Arduino. I'm going to, you know, now turn over to my computer over here, and I have like a little media player that's going to just play like a little sine wave. I think this is a, 50 hertz? Yeah, it's a 50 hertz sine wave, but it doesn't matter. It's music, right? So every single time Arduino detects a voltage on that signal, right, it's going to blink this LED, this Arduino LED. So watch, I'm going to hit the pause, and if everything's fine, it's going to start blinking every time it detects a signal, and 10 seconds after the first signal was detected, it's going to turn the whole thing on, and these guys will light up, right? And it's all automatic. So, see, it's blinking. That was one. There's another one. There's another one, another one, another one, another one. Come on. Click. There you go. See? So, it thought, well, here's music, and turned the whole thing on. And it is on. You can see these guys, right? They're on. Now I'm going to stop the music. And when I stop the music, Arduino about 5 seconds later is going to be like, okay, there's no music. There's no music. You see how that LED is now blinking in a different way, right? It's just kind of steady. So it's going to blink like that for 10 minutes. And after it had no music for 10 minutes, it's going to shut the whole thing off. So I'm not going to make you wait and sit here for 10 minutes. Obviously, it would be too boring. But, you know, and that's basically the setup, right? So now when I hit pause on my music and get distracted, my tube amp is not going to overheat my room or set the house on fire or, God forbid, overcook my pancakes, which is the most important use for a tube amplifier.